Okay, so this video is just going to cover how to write the electron configuration of an ion. So if you don't understand how to write the electron configurations of an atom, you'll want to go back and watch my video on that, because this is going to be a pretty short video. So what are the differences between the electron configurations of atoms and the electron configurations of ions? Let's take a look at just a couple examples here. So let's say that you were asked to write the electron configuration of Mg+2, which is the magnesium ion. A couple of things you need to realize. Normally, magnesium would have 12 electrons. It's element number 12 on the periodic table. And atoms always have the same number of protons and electrons because they are electrically neutral. Protons have a positive charge, electrons have a negative charge. So magnesium normally has 12 positive particles, protons, and 12 negative particles, electrons. And that gives it a net charge of 0, a neutral charge. However, when magnesium becomes an ion, when it becomes Mg+2, it loses 2 of its electrons. So in a magnesium ion, magnesium has 12 protons still, that will not change, but it only has 10 electrons. So 12 positive particles and 10 negative particles gives you a net charge of +2. Now, all you really need to know for electron configurations is how many electrons you're trying to arrange. So magnesium, Mg+2, the magnesium ion, has 10 electrons. So when you write the electron configuration, you need to fill or configure 10 of them. So you'll do this just like we've done before in the previous video. You'll start with 1s2, then you'll go to 2s2, and then you'll go to 2p6, and you'll actually stop there. So you'll notice that this superscript here, this exponent 2, another 2, and 6 adds up to 10, and that's the number we were trying to reach. So the magnesium ion actually has the same electron configuration as neon. So again, when you're doing ions, the most important thing you need to ask yourself is how many electrons the ion has and how this is different than when it's an atom. So let me clear this off here and let's look at one more example. So we saw a positively charged ion, also known as a cation, but let's look at a negatively charged ion, also known as an anion. So in this case, we've got O-2, or the oxide ion. Now, oxygen normally would have 8 electrons. So a normal atom of oxygen has 8, but this is an ion. The -2 tells me that this particular atom has gained 2 extra electrons, and it has given it a net charge of -2. Oxygen has 8 protons. Normally, it'll have 8 electrons, and it will have 8 positive particles, 8 negative particles, and it'll be neutral. However, in an oxide ion, oxygen has 2 extra electrons. So it has its 8 protons and 10 electrons, which gives it a net charge of -2. What you're concerned with when you're trying to write an electron configuration is just how many electrons does this thing have? Well, it has 10. So when you write your configuration, I'm going to clear off some space here on the screen so we can see this a little better. So when you write configuration, you're going to go 1s2, 2s2, 2p6, because you've got 10 electrons, and 2 in the 1s sublevel, 2 in the 2s sublevel, and 6 in the 2p sublevel, which adds up to 10, which is the number you were going for. So just make sure you realize that the configurations of a neutral atom and its ion are quite different, and the main thing you need to focus on is simply the number of electrons that are present in the ion. Then you will follow all the rules that you normally follow when you write the electron configuration for an atom.